Question 6. The diagram below shows a uniform rod AB of length 3.8 and weight 180. The rod is resting horizontally in equilibrium as shown, and it gives us the diagram and it gives us some lengths. An object of weight W newtons is placed at A. Given that W is 69, find the magnitudes of the reaction at C and the reaction at D. Okay, so we can just add to the diagram they've given us. So we'll put a downwards weight here of 69 newtons. So that doesn't need the G because this is weight in newtons. Our object is resting on the support at C and D. So we need to put reaction forces here and here pushing upwards. So I'll call those RC and RD. We have the weight of the rod itself, and because it's uniform, it acts at the midpoint. Okay, so that's probably about there. We'll label all the lengths in as well. So again, that is weight, so it doesn't need the G. Okay, so we know that the uniform rod is of length 3.8, so half of that is 1.9. But let's try and put all the measurements in. So dB is 0.8. So if that whole distance is half of 3.8 from here to here, okay, so that's 1.9. Take away 0.8 and you get 1.1. So 1.1 from D to the centre. We know that C to D is 1.8. So if that's 1.1, then that's 0.7. And then again, from the centre to the edge is 1.9, and we've got 0.7 there already, so this is then 1.2. So make sure you have all your individual gaps labelled as your lengths on your picture. Okay, so now we're ready to do the process. We need to take moments, so we're going to choose a point to take our moments about. And ideally, I want to choose a point where we don't have a force that we know. Okay, so I could choose either point C or point D. And the reason that's easier is because then you don't have two unknown forces in your equation. Okay, we only really want one unknown force in our equation, and then we'll be able to work it out immediately. Otherwise, you'll end up with simultaneous equations, which is not helpful, really. So I will choose to take moments about point C. I could equally well choose to take it about point D, and I'll show you that one as well. But if I take moments about C, what I'm doing, I'll use my pencil to help you see what's happening, is I'm imagining that this is fixed and that the support at D isn't there. Okay, and if you twist at that point, okay, the only arrow out of the ones that are going to be causing this twist, the only arrow that's making it go that way is the 180. Okay, we've got three other arrows. No, we've got three other arrows. We've got this one here at RC that's not going to come into it, because if you push at the fixed point, it's not going to have any effect. So you can ignore RC. You've got the 69 here. You've got the RD here. They are helping each other, because if I push this way and imagine it could turn that way, both the RD and the 69 are going the way they're pointing. Okay, so when we're taking moments about a pivot point, we need to think about which forces are helping each other and which forces are opposing. Okay, so the way I would write it down is I would say that the moments of the forces causing a turn in one direction, perhaps anti-clockwise, equal the moments of the force that are causing the turn in the other direction, clockwise. You can do it as 1 minus the other equals 0. That's also absolutely fine. So I'm going to say, taking moments about this pivot point at C, if I imagine going anti-clockwise, then I've got RD and I've got force A both helping each other. So what I would write down, remember it's the force times the distance, I would say it's RD multiplied by a total distance of 1.8 from the pivot point, plus 69 times a total distance of 1.2 from the pivot point. And then that will be balanced by, will be equal to the effect of the 180, which is trying to turn it that way. So that would be 180 times 0.7. Okay, you can take moments about different places, but if you take it about C, then that is the equation we are looking for. So that's got one unknown, which we can then work out. So I can say 180 times 0.7. That term will hop across and subtract. So minus 69 times 1.2. That gives me 43.2. Divide by 1.8. And we get RD is 24. It's not always going to be a nice whole number, but this one is. And that's 24 newtons. I could take moments about D to work out the other force, and I did say I was going to show you that, but realistically I don't need to. Once I've got 3 out of my 4 forces, once I've only got one unknown force to find, I can use the idea that I can resolve. So if I just resolve vertically, I can say that RC upwards plus RD upwards is balanced by 69 plus 180. So that doesn't use any distances at all. But we already know that RD is 24. So I can say 69 add 180 take away 24 gives me 225. Okay, and those are the 6 marks. It doesn't actually feel like you have to write very much down for your 6 marks, but there's a lot of marks going because you've got to think about things and get them right. If you did do moments about D, which you don't need to if you've done this, but if you did take moments about D instead, let's have a look what would be happening here. The pivot point would be at D. Again, imagine twisting one way, and this time the 69 and the 180 are both twisting clockwise. They're trying to make it turn that way. So they're the ones that are helping each other. And pushing it the other way is the reaction at C. Okay, there isn't anything on this side because there's no force on this side of the pivot. So I'm only looking on one side of the pivot. So maybe it's a little bit easier, this one. You can see a little bit more clearly that these two are pushing one way, and that's being balanced by that one pushing that way. So if I was going to write the moments about point D, I would say that the 69 needs to be multiplied by that total distance, and that adds up to 3, plus the 180 multiplied by the distance from the pivot, which is 1.1, will equal RC times its distance from the pivot, which is 1.8. Okay, and just to show you, 69 times 3 plus 180 times 1.1 gives us 405. Divide that by 1.8 and we get 225, which is what we had to start with. And then you can resolve vertically and get RD is 24. You can, if you want to do moments twice, do this and get the 2 answers. It's totally up to you.